Okay, so today we're going to be writing some rules. Okay, so the most important thing that you guys do when you're writing a rule for a transformation is you're having to kind of think backwards. Okay, so you're going to look at what's happening and think kind of backwards, like what did I do to get this new shape where it is, right? And so what we want to do, make sure that we're doing is that we're starting with the pre-image, and we're going to the image. Okay, now, if we're going, how do we know which one is which when we start? What does the image have that the pre-image doesn't have? Yeah, those little like apostrophes or primes, okay? So this is the shape where the letters have primes. Okay. So this shape has, all of its letters have the little apostrophes, like they're apostrophe looking and they have primes. Okay. All right, so we're starting on the shape without them, and we're moving to the shape with them, okay? We're going to then check, okay, you guys have learned about 3 different types of transformations, so then we're going to check and see, we've learned about a translation, right? So we're going to check, is it a slide, okay? Or maybe it might be a reflection, that's a flip, right? Or it might be what you guys learned about yesterday, which is a rotation. Okay? So it's going to be one of these 3 things. Okay? And depending on which one, we're going to write some specific information in a rule about that type of transformation. Okay? All right. So, do you guys have questions about anything so far? No? Okay, so let's look at number 1. Okay, so what I'm going to do with number 1 is I'm going to take my trace paper and I'm going to trace the original. Which one's the original? The one on the right or the one on the left? Which one does not have primes? The right. Okay, so trace the one on the right. Okay. All right, and can I just slide it to get it onto the next one? Yeah. Okay, so I always go through and I check for translation first. Then I check for reflection, then I check for rotation. But this one, I can get it by just sliding, right? So this one is a translation, so we're going to write translation. And if it is a translation, I want you to write a rule for it. You can either write it in coordinate notation or you can write it in component vector form. But I'm just going to go ahead and write it in coordinate notation. So x comma y maps on 2. And remember, when you're writing a rule for a translation, it's x plus or minus how much it moved, right? And then y plus or minus how much it moved. So to check what numbers I'm going to get in here, okay, I'm going to take one of my points. I'll just take the x and see what did I have to do to slide it over to x prime. And so I went left 1, 2, 3, 4 spaces. So how would I write that in my coordinate rule here? X minus 4. Okay. And then I went down how many? 1, 2, 3, 4. So that would be y minus 4 because you went down. Okay? Now, how would I write this if I wanted to write it in the component form of a vector? What would that look like? I could also write it in that form. You remember what component form of vector looks like? Those pointy brackets. And instead of having the x's and y's, remember I just have the numbers, so what would it be? -4, -4. Okay? So that's another way to write it. Do you guys remember there were two different ways to write that? Okay. All right. Okay, so let's take a look at number 2. Okay. Let's have you guys try number 2. So for number 2, which one are you going to trace? The image on the right or the one on the left? Which one has no primes? This one, right? R, S, P, and then Q's over here, right? But it also doesn't have a prime. So let's go ahead and trace that. Okay, can I just slide it to get it to the next one? Yeah, okay. All I have to do is just slide that shape and it moves. So that's a translation again. So I'm going to go ahead and write it's a translation. And let's write my coordinate rule. Okay, so I'm going to pick 2 points. Maybe I'll pick S and see how I get to S prime. Okay, so do I have to go right or left? Left. 1, 2, 3, 4, 5 spaces left. And then up or down? Down. Down 1, 2. Okay, so I went left 5, so how do I write that? X minus 5. And down 2. How do I write that? Y minus 2. Okay, or I could write it in component form of the vector. What would the component form of the vector be? Negative 5, comma, negative 2. Okay? Yes. Okay, are there questions on how we did that one? Okay, what I'd like you guys to do right now are to try numbers 3 and 4. Okay, I'm going to give you guys a minute to try those, and then we'll check your work. Go ahead and check your work right now. Okay, so on this one, did you guys get, you had to go, this was the pre-image, right? The bottom one, moving to the top one, so you had to go left 1, up 2. So did you guys get left 1, up 2 for that? Okay. And then now let's take a look at the next one. Did you have to move left or right at all? No, okay. So when you don't have to move left or right at all, remember it's like writing x plus 0, which we don't really need to write the plus 0. But if you write it in the component form of the vector, you need to put that 0 as a placeholder. Does that make sense? Showing that there was no directional change left to right, okay? So those of you that wrote the component form of the vector, did you get it right? Raise your hand if you did. Okay, cool. All right. Okay, so let's go ahead and let's take a look at the next figure. Okay, so on the next figure, let's go ahead and trace the pre-image. So let's trace the one without the apostrophes. So that would be this upper one. Okay, now what happens if I just slide it? Is it matching up? No. Okay, so if I try to slide and it doesn't match up, what I'm going to check for next is maybe it's a reflection instead of a translation. Okay, so I'm actually going to take my whole patty paper and I'm going to flip it and see if then is there a way that it will match up. So if I flip, does it match up? Yeah, okay. So if I can do a flip, some of them, it's easy to see where the line of reflection is. Like this one, it's pretty easy to see where it is, right? But if you're not sure where it is, you can actually fold your trace paper over. And the line of the fold, that would be the line of the reflection, right? So by actually folding my trace paper, I can see where it is, okay? So where's your line of reflection on this one? The x-axis, this is your line of reflection, right? So we are going to write this is a reflection. And we need to name what line it's reflecting over. So this is a reflection across the x-axis. Okay. All right. So let's take a look at the next one. Okay, which one is the pre-image? The upper image or the lower image? This one has prime, so this one is the pre-image, right? The original, no primes. Okay, so I'm going to trace that one over. Okay, if I just slide it, is it lining up? So is it a translation? No. Okay, what if I flip it? If I flip it, does it line up? Okay, so what line am I reflecting this one over? Can you guys see? If you're not sure, you can kind of take your paper and fold so that it matches up, right? And you can see where that fold line is created. There, it's matched up, so where's that fold line running straight through? X-axis, right? Does that make sense? Okay. So we are doing another reflection here across the x-axis. Okay. Are there questions on that one? Yes? Oh, yeah. I wrote it here, but I forgot it here. Thank you. Yeah, the question was on number 4, wasn't it a -3? It was. I wrote -3 here, but I forgot to put my negative on the component form. So can you guys add that? You didn't get that already. Okay, thank you for pointing that out. All right. Okay, let's flip over to the back. Okay, so let's go to the back. Okay, so this one, it's kind of hard to see on this one where your image and your pre-image are because some of the points are like overlapping. But do you see here how that one doesn't have an apostrophe and that one doesn't have an apostrophe? So let me help you guys to trace the shape. This, I know it's hard, this one's really hard to tell because the way they did the points, a lot of them are overlapping, but that's your pre-image. Okay, so can you guys trace that over? All right, so now if I just slide, am I lining up with the other one, which is right there? No. Okay, so what do I have to do actually to line it up with the other one? I have to flip, right? Now, if you're having trouble seeing where the line of reflection is, you can fold this back, and then this would show you the line of reflection. Now, another method for finding the line of reflection, if the folding thing is confusing to you, is take the prime and the original and count how many spaces are between them and put a point in the middle, right? And then take another prime in the original and find the middle there, and that's going to create your line of reflection. So can everyone now see where our line of reflection is? Here's your line of reflection. Okay, so this one, it's a reflection across, what do I call this line? Is it the x-axis? Is it the y-axis? No. Okay, so what axis is this line cutting through? It's cutting through the x-axis, so it's going to have an x in its equation. Okay. What number is it cutting through x at? Here's the origin, so 1, 2, 3. So it's the line x equals 3. Okay, that is the line of reflection. So if you get a reflection, you're not just writing reflection, you're telling me where it's reflecting across, so whether it's an axis or a special line. Okay, does that make sense? All right, let's take a look at number 8. Okay, so number 8, if I trace the original, it's down here. Is it a translation? Can I just translate and slide it up there? No, okay. Is it a flip? Is it a reflection? If I flip it, can I then get it to line up? Yes, okay. So, where is your line of reflection on this one? You guys see it's right here? Yeah. So what axis is this? X, okay. So this is a reflection. Across the x-axis. Okay, why don't you guys try number 9? See if you guys can try number 9. Okay, so let's check your work. Did you guys draw your line of reflection right there? Yeah. Okay. So what is this line? Okay, it's crossing, it's crossing at -1. What axis is it crossing at -1? Yeah. So we're going to write down this is a reflection across x equals -1 because it's crossing x at -1. Now, I have a question. What if your reflection line was horizontal, but instead of being on the x-axis, it was actually like down here? What would your equation be for a line that crossed somewhere down here? Y equals whatever the number was, like -3, -4, -5. What is the equation of the line that runs diagonal from corner to corner like that? Do you guys remember it? Y equals x, right? Y equals x. Remember that one with the positive slope of 1/1 that goes through the origin? What's the equation of the line that goes like this? You guys remember that one? Y equals -x because it has a negative slope, okay? So remember, if it has a y and an x, it's going to be diagonal. If it's just y or just x, that means it's vertical or horizontal, okay? Okay, let's take a look at this one. Okay, so this one, let's trace our original. Which one's our original? The one on the right or the one on the left? The one on the right, this one, right? There's TSU. This is my original figure. At first, I'm like, oh, okay, maybe this is a reflection. Maybe it's reflecting over this line. So if I try to flip it, does that end up overlapping? And then I'm like thinking, okay, well, maybe it's just a slide. But if I just slide it, does it work? And then I think, okay, well, maybe it's a reflection across the diagonal line. So if I draw a diagonal line and reflect that diagonal, is that working? That's not working either, right? So if it's not a translation and it's not a reflection, what must it be? Okay, so I'm going to draw a cross through the middle of the origin, and I'm going to see which direction and how much I need to rotate, okay? So if I go, the quickest way would be going to the left. So am I going clockwise or counterclockwise? Clockwise. Okay, and then how much did I rotate? 90 degrees, okay? So this was a rotation 90 degrees clockwise. Now, is there another possible answer that could have been correct? Like, what if when I started rotating, I went the other way? What if I went counterclockwise, 90, and then I went 180, and then I went 270? Would I be able to get there? Yeah. So remember, when you're doing rotation, there's two possible answers, right? The other possible answer on this one would be, or you could have gone 270 degrees counter counterclockwise, right? But on the homework, I'm not going to require you to write both. Just one would be fine. Just know that there's two possible answers. Does that make sense for rotation? Okay. All right, so you can use either direction. Okay, so I want you guys to see if you can figure out numbers 11 and 12. Okay, so I'm going to give you guys a moment to give those a try. Try 11 and 12 right now. Okay, so let's go ahead and check your work. Okay, for number 11, if you traced over the image and you tried to reflect it or you tried to slide it, it wasn't working, right? Okay, so let's go ahead and try rotating it. So I'm going to go 90 and then 180, right? So did you guys get it was a rotation of 180 degrees? Okay, now remember, 180 degrees is one of those ones where we don't have to specify a direction because clockwise and counterclockwise are the same thing when doing 180, right? Okay, let's take a look at the last one. Okay, so on the last one, when you traced over the image, what was the quickest way to get to the answer? Yeah, this way, which is actually which way? Counterclockwise, right? Okay, and how many degrees counterclockwise? 90 degrees. Now, what would have produced the same outcome if we went the opposite direction? Yeah. Okay, clockwise 270 would have produced the same outcome. Okay, so we could have also had 270 clockwise. All right. Okay, are there questions on anything we did today?